Hi friends, welcome to my channel Path of Physics. Today I am here with the topic transmission of heat. So we can start with heat transfer. The passage of thermal energy from a body at higher temperature to a body at lower temperature is called heat transfer. It occurs by three processes: conduction, convection, and radiation. In this video, we are mainly going to discuss about conduction. Conduction is the process of transfer of energy without the actual movement of the particles of the medium due to temperature difference between two parts of the body. No atoms or molecules are transferred. Uh, Conduction is a slow process. Consider Consider an example. When a metal bar is heated, the metal bar has two ends. At one end, heat is applied. The atoms at that end absorb thermal energy and they start to vibrate vigorously. This thermal energy is converted to vibrational energy and is transferred to neighboring atoms. In this way, thermal energy is converted to vibrational energy and it is transferred from hot end to cold end. This is how conduction works. This is how the colder end becomes hot. Conduction is a slow process. In good conductors like metals, free electrons are responsible for conduction. Metals are good conductors of heat. Examples of bad conductors are liquids, air, wood, rubber, etc. Now, mercury is a liquid metal. Although it is a liquid, it is a good conductor of heat since it is a metal. Next, we have to learn about steady state and temperature gradient. For that, consider a metal bar. It has two ends, A and B. From end A, heat is supplied. Heat flows from end A to end B. Consider a layer of thickness X in the metal bar. Its one side temperature is theta 1 and the other side temperature is theta 2. The heat entering this layer is used for three purposes. One is to increase the temperature of the layer. Some of the heat is radiated to the surroundings and the remaining part of the heat is transferred to the next layer, nearby layer. During steady state, after heating this metal bar for some time, it reaches a condition called steady state. During steady state, temperature at any one point will remain constant with time. For example, if we consider this part, its temperature is theta 1. Theta 1 remains constant with time. If we consider another one part, its temperature is theta 2. That also remains constant with time. If we take another one point here, the temperature of that point with time will remain constant. So the temperature at any one point will remain constant with time during steady state, and the temperature at two different points will be different. Here theta 1 and theta 2 are not equal. They are different. Theta 1 is greater than theta 2 because heat flows from A to B and the quantity of heat flowing per second through each layer remains constant. So during steady state, these three are the conditions to be satisfied. Next, we have to learn about temperature gradient. During steady state, the rate of fall of temperature with distance along the direction of heat flow is called temperature gradient. It is given by the equation theta 1 minus theta 2 by x. It is a temperature gradient of this layer is theta 1 minus theta 2 by x. It is the rate of fall of temperature with distance along the direction. It is the rate of fall of temperature with distance along the direction of heat flow. Now, if the fall of temperature per unit length is not uniform, the temperature gradient is equal to, we use the limiting case, limit delta x tends to 0, delta theta by delta x which is equal to d theta by dx. If the fall of temperature per unit length is not uniform, means if we consider a unit length here the fall of temperature is different. If we consider another one unit length here also the fall of temperature is different. So it is different in different unit lengths. So it's not uniform, it's not same. So we consider the limiting case. Limit delta x tends to 0, delta theta by delta x equals d theta by dx, where delta theta is the temperature difference over a small distance delta x, or d theta is temperature difference over a small distance dx. Now next we have to learn about thermal conductivity and the law of heat conduction. During steady state, the quantity of heat flowing normal to the cross-section area of heat conductor is proportional to cross-sectional area, temperature gradient and time t. So now we are going to put all this in equation. So once more I will explain. During steady state, this metal bar is now at steady state. During steady state, the quantity of heat flowing through this layer is proportional to its cross-sectional area, temperature gradient theta 1 minus theta 2 by x, and time. So now we have put all this into an equation. This proportionality symbol is removed and is replaced by a proportionality constant. Q is equal to Ka into theta 1 minus theta 2 by x into T, where K is the coefficient of thermal conductivity. This is known as the law of heat conduction. The coefficient of thermal conductivity K of a material is defined as quantity of heat flowing normally per second through unit area of the substance per unit temperature gradient. K, from this equation I have derived the equation for K. K is equal to Qx by A into theta 1 minus theta 2 by theta 2 into T, where Q is the amount quantity of heat, X is the thickness of this layer, and A is its cross-sectional area, theta 1 minus theta 2 is the temperature difference, and T is the time. SI unit of K is watt meter inverse Kelvin inverse. Its dimensional formula is ml T raised to 3 K raised to minus 1. Now I am going to say about examples of thermal conduction in daily life. Cooking utensils are provided with wooden handles because wood is an insulator of heat. If metal handles were given instead of wooden handles, if we hold the utensils, our hand would get burned. But wood is an insulator, so if we hold the utensil, our hand would not get burned. Now ice is packed in sawdust. Ice is packed in sawdust. Sawdust and mixture of air act as insulators, so it does not allow ice to melt easily. In winters, metals appear colder than wood because in winter our body is at higher temperature than the surrounding objects. So if we touch a metal object, heat flows from our body to the metal, so we feel cold. Birds swell their feathers in winter. By doing so, the birds enclose air between their bodies and the feathers. Air is a poor conductor, so it prevents loss of heat from the body of the bird and it maintains its body temperature. That's all for today. If you like the video, please like it, share and subscribe. Thank you.